Hello students, today we're going to be learning about parallel and perpendicular slope. So our goal for today is to be able to determine the slope of a line between 2 points, as well as differentiate between the slopes of parallel lines and perpendicular lines. So let's get started. I really should put like a tab or something so it's easy to get to the page that we're on. And today is September 23rd, 2020. All right, so let's do a little bit of review about slope. Now, slope is a concept that I believe is learned in middle school, and then you learn it again in algebra. So we're going to see it yet again here in geometry. I'm looking for my green pen. Where did my green pen go? I think I lost it to the void. Oh, I will use my off green. So just as a little review, slope is the ratio of vertical change of a line to the horizontal change. Oh, let me put that on the screen. My goodness, it sure is a morning, huh? Here we go. So a few things to know about this definition. Ratio means that you're comparing one quantity to another, but remember that this is something that can be written as a fraction, which you'll see slope most of the time written as a fraction. Vertical change is talking about the change in the y values, because if we remember, in the coordinate grid, the vertical axis is the y-axis, and then the horizontal is the x-axis. So this will be the change of the y values over the change in the x values. We often see this written in a very particular form. Rise over run is what it's called a lot of the time. That rise is how much the graph rises, and then the run is how much it runs along the ground or goes horizontally. However, if we don't have a graph and all we're given is a set of points, we have to use a little formula. So the rise is found by the change in the x value or y values, so the difference between them, and then the difference or change in the x values. And there we have our...
Good morning, Gray Wolf. This is a reminder that masks are required at all times when you enter the building.
Well, let me pause.
Please practice social.
All right, sorry for that little pause. We had an announcement. So the change in the y's over the change in the x's is the formula for slope, which is often written as the letter m. Now, I can't tell you why m, but... So let's do a little example where we find the slope of AB given point A is at -2, 5, and point B is at 6, -1. So I'm going to remember that formula. And I'm going to take my y values. Oh, this is going to smear. Maybe I shouldn't. I'll underline. My y values, I'm going to underline in that pink color. And my x values in blue, kind of trying to make it matchy-matchy with my formula up there. And I'm going to do y minus y. So if I make this my 2's, y minus y on top. So that'll be -1 minus 5. And then on bottom, my x2 minus x1. So 6 minus a -2. Now, I think the number one mistake I see students make is getting mixed up with these operations. So we have to remember, if we are subtracting a negative number, that's becoming a positive. And when we subtract a number from an already negative number, think about it like adding the two numbers together, but then make it negative. So -1 minus 5 more becomes a -6. And then 6 minus a -2 becomes 6 plus 2. I just want to make that very clear. And then we can do 6 plus 2 to get 8. And lastly, we got to simplify this fraction, which I'm kind of running low on room there. So I'm just going to do it over here. Let's do this. So we're going to simplify that fraction and get, let's see, -6/8. Both of those are even numbers, so I can simplify them by a factor of 2 to get -3/4. And now I can't simplify that anymore, so that'll be my final answer. -3/4. See, everything in math builds. We have our simplifying fractions. That's from a while ago, but it does come in handy all the time. All right. So again, every time you're finding the slope of a line between 2 points, you're just going to use this little formula and simplify that fraction. So next we have a few important bits of information. So we are talking about parallel and perpendicular slope. So parallel lines have the same slope. Same slope, it's the same number. So if we wanted to find a line perpendicular to this one that we just found, we would have a slope of -3/4, the exact same number. If your slope is 2, the slope of the parallel line is 2. Always going to be the same. So what about perpendicular lines? Well, these guys have what's called opposite reciprocal slopes. So opposite reciprocal means you're going to change the sign and flip the fraction. So it's important to note that opposite reciprocal, you have to do both. You can't do opposite slopes, and you can't just do reciprocal slopes. You have to do opposite reciprocal. You need to change the sign every time, and you need to flip the fraction every time. So let's see a few examples of opposite reciprocal slopes. So if I gave you a slope of 3/4, the opposite reciprocal, I'm going to change the sign. So it was positive. I'm now going to make it negative. And I'm going to flip that fraction. So 3 was originally on top. 3 is going to go to the bottom. 4 is on bottom. 4 is going to come to the top. -4/3. What about one that the slope is 2? Well, this is an important time to remember that there's a denominator of 1 for every number. It's invisible, it's assumed, but we're talking about 2 pieces out of a whole of 1. So this is kind of like 2/1. So when we change the sign, we're going to make it negative. And when we flip the fraction, 2 is on top, so 2 will now be on bottom. So 2 and -1/2 are reciprocal, opposite reciprocal slopes. What if we had -7/8? Again, I'm going to change the sign. So it was negative, it's now going to become positive. And then 7 will go to the bottom, 8 to the top. -7/8 and 8/7. Now this one tends to get a little bit tricky. What if we just had a slope of 1? Well, I'm going to change the sign, and it'll become negative, but again, 1 is just that whole number, so it's technically over 1, but that's just 1/1. So when I flip it, it's still going to be 1/1. So the opposite reciprocal of 1 is just -1. So that one can be a little bit tricky for people. So that's an important example. It's a power example. All right, we have one more bit of something for us to review. This should be familiar to quite a few of y'all. Slope intercept form. So because we're talking about slope of lines, slope intercept form is an important part of this. And that's that form that's y equals mx plus b. Again, we mentioned that m is our slope, and that means b is our intercept. So whenever you're looking at the equation of a line, hold on, I have a guess. Okay, sorry about that. That's one of the pains of recording while at school, but I really don't want to do it at home because when I'm at home, I want to relax. Okay, so where was I? Ah, yes. So because we're comparing slopes of different lines, slope intercept form is great because we can see the slope right there. So if m is the same, that means it has the same slope, so we have parallel lines. And if m is I have another guest at the door. Okay, let's see who this is.
Won't give you the work, it's not gonna be with you, right?
Sorry, folks. Luckily, this is a YouTube video, so you guys can just skip ahead. So, if m is the opposite reciprocal, then of course we have perpendicular lines. So whenever we're identifying if we have the equation y equals 2x minus 4 and y equals 2x plus 10. There's a lot of information here, but I only care to look right here. And I can see, hey, this one's a 2 and this one's a 2. So because both of those slopes are 2, I have myself parallel lines. Then if I have y equals negative 3 over 4x minus 2, and y equals positive 4/3 x minus 2. Remember, we're going to look right here at the slope. These two may be the same, but those are just y-intercepts. They don't matter when it comes to lines being parallel or perpendicular. That's decided by this number right here. So I can see this one's negative, this one's positive. That's promising. And then 3 over 4, 4 over 3. Ooh, I have myself some opposite reciprocals. So these guys are perpendicular. And let's take a look at one more example. Y equals 2x plus 7, and y equals 1/2 x minus 4. So here it might be tempted to go, oh, we have 2 and 1/2. Those are reciprocals. But we're missing the opposite part. It would have to be either a -2 or a -1/2 for them to be opposite reciprocals. So these lines do not have a parallel or perpendicular relationship. So these are neither parallel nor perpendicular. They don't meet that criteria. They're intersecting at some point, but not in any special way. So just a quick recap, because there were a lot of little intrusions. We learned, or rather, I guess I should say reviewed, the formula for slope, which is y2 minus y1 over x2 minus x1. We did an example of finding the slope between 2 points. And then we learned that parallel lines have the same slope and perpendicular lines have opposite reciprocal slopes, meaning we have to change the sign and flip the fraction. We saw a few examples of finding the opposite reciprocal slope, and then we reviewed what slope-intercept form was and applied that to our new knowledge about parallel and perpendicular lines. So we can look at the slope in slope-intercept form and determine whether lines are parallel or perpendicular based on their slopes. All right, guys, so there's a short assignment in Schoology as usual, parallel and perpendicular slopes. We have 10 questions in total. The first 2 are going to be based on our definitions, so make sure you have those definitions, check over the notes. The next 2, you're going to find the slope of a line that passes through 2 points. So that's going to be just like this example. You're going to use that slope formula. Number 5, you're going to find opposite reciprocal slopes. So just like these examples. And then the next 3 questions are going to ask you whether lines are parallel, perpendicular, or neither, just giving you the slope. So if I say this line has a slope of 1 and this line has a slope of 1, are they parallel, perpendicular, or neither? And lastly, the last 2 questions are going to be like these end examples here. It's going to give you 2 equations and you have to figure out whether they're parallel, perpendicular, or neither. All right, guys, I will catch you for the next lesson over more parallel and perpendicular line stuff, but with the point slope formula. See you tomorrow.